Welcome to The Explainer. Today, we are diving into a really critical piece of infrastructure for any serious AI application, the LLM Gateway. Look, if you're building with models from places like OpenAI, Anthropic, or Google, and you're starting to think about scale, then this is definitely for you.
All right, so here's the plan. First, we're going to talk about the problem. The headaches that pop up when you try to scale your AI prototypes. Then we'll introduce the gateway as the hero of our story. We'll get into how it actually works, talk about the huge benefits for performance and reliability, and wrap up with how you can pick the right one to build an AI stack that's ready for anything. So let's set the scene. You've built this awesome AI prototype. It works, it's cool, everybody's excited about it. But what happens when you try to take that little experiment and turn it into a real, live application that people depend on? Well, that's usually where the pain starts. Yeah, as soon as you move from that nice, clean proof of concept to a real-world app that's got to serve, I don't know, thousands of users, a whole new world of challenges just appears out of nowhere. Suddenly, it's not about just tweaking a prompt anymore. It's about building a system that doesn't fall over under pressure. All of a sudden, you're in this messy, fragmented world. Every single LLM provider has its own API, its own way of doing things, its own little quirks. And if you try to manage all that mess directly inside your app's code, you end up with a system that's super brittle. It breaks all the time. It slows down innovation because trying out a new model becomes this huge project, and it just opens you up to some pretty serious risks. This is exactly where the idea of an LLM gateway comes in, and honestly, becomes a lifesaver. It's designed to step right into that chaos and act as one single, unified layer of control for your entire AI setup. The easiest way to think about it is like a smart traffic cop for your AI calls, or maybe a reverse proxy if you're a networking person. But it's built specifically for the wild world of large language models. It's the specialized piece of software that handles all the nitty-gritty, provider-specific details so your main application doesn't have to worry about them. And what's so cool about this, when you see it laid out, is just how clean your architecture becomes. Your application, it only needs to talk to one place, the gateway. That's it. The gateway then takes on the really hard job of routing, translating, and managing every single interaction with all those different LLM providers on the back end. So how does this gateway actually fix those scaling headaches we were just talking about? Okay, let's get into its core functions and see what makes it tick. And this table really shows you the before and after so clearly. So without a gateway, right, if your main LLM provider goes down, poof, your application goes down too. But with the gateway, it can instantly detect that failure and just automatically reroute the request to a backup, maybe over to Claude or Gemini, and your users never even notice. It really does turn that chaos into control. And these are the features that make it all happen. The gateway takes all incoming requests and puts them in a standard format. It juggles all your different API keys so you don't get rate limited, and it gives you one single dashboard to see what's going on everywhere. All these things work together to completely separate your application's logic from whatever LLM provider you happen to be using today. And the payoff for doing this isn't just about making life more convenient. No, it delivers real, measurable benefits in performance, reliability, and maintainability. And those three things are just non-negotiable for any serious production system. Now, you might be thinking, okay, but if I add another layer, isn't that going to slow things down? It's a fair question, but with modern gateways, that's just not the case. The really high-performance ones, built in languages like Go, can add as little as 11 to 15 microseconds of overhead. That's basically nothing. You'll never notice it, even at a massive scale. And look, this isn't just theory. Take this benchmark from Bifrost, which is a great open-source gateway. It shows what's possible when the architecture is really optimized. A well-built gateway doesn't just add features, it can actually make your whole system run faster and more efficiently because it's so smart about managing connections and resources. So just for a second, let's use Bifrost as a quick example of what a state-of-the-art, high-performance gateway looks like. It's open source, it's built for pure speed, and it really has all those core ideas we've been talking about baked right in, from automatic fallbacks to built-in observability. And visually, the performance gap here is just huge. This chart is showing what we call P99 latency. Basically, it's the experience of your unluckiest 1% of users. For any app that people actually use, keeping that number as low as possible is so important. It ensures that everyone has a fast, reliable experience, not just the average person. Okay, so let's say you're on board. You're thinking, I need one of these. The next question is obvious.
how in the world do you pick the right LLM gateway for your team and your project?
The whole process is pretty simple, really. You choose one, you integrate it, you monitor it, and you scale it up. But let's be honest, that first step, the choosing, is everything. Picking the right tool for the job from the get-go is going to save you so many headaches later on. So here's a handy little checklist to help you think it through. You absolutely have to benchmark its performance for your use case. Make sure it supports all the models you're using now and the ones you might want to use in the future. And please check for those production-ready features, like built-in monitoring and an active community that's actually maintaining the project. At the end of the day, using a gateway isn't just some small technical fix. It's a really strategic choice you're making to build an AI stack that's more robust, more reliable, and ready for whatever comes next. So here's the bottom line, the big takeaway. An LLM gateway completely transforms your architecture. You go from having a fragile prototype that's hard-coded to one provider and is always at risk of an outage, to having a rock-solid provider-agnostic production system with automatic failovers and one place to see everything. It is the foundation for doing AI development the right way.
And this quote just nails it. By taking away all that provider complexity and giving you a central point of control, a gateway lets your engineering team focus on what they're actually good at, building incredible products, not wrestling with infrastructure plumbing.
And that's really the question I want to leave you with. As you scale up your own AI projects, take a hard look at your architecture. Putting a high-performance gateway in place early in the process, it is one of the smartest things you can do to set your team and your entire application up for success in the long run.